Okay, so what we have here is a imaginary number, and that's represented by the variable I, and it usually means I equals -1. An imaginary number is it's basically the square root of any negative number. So this -4, the way it would be simplified is you would break it into two parts. You'd do the square root of -1 times the square root of 4, because that multiplied would equal -4. But then, because the square root of -4 equals 2, that would equal and then the square root of -1 equals I. It would be 2I.
Let's try something a little more difficult. Normally, this problem would boil down to a simple simplification, such as the square root of 4 multiplied by the square root of 6. But since this is negative, we have to place a negative square root right beside it. And since that's a negative number and a radical, it would come out to I, since it's -1 and a radical, it would come out to I times 2 times radical 6. And it would come out to 2I radical 6.
Alright, so the next part is complex numbers. And a complex number is of the form a plus bi, where a is the real number and bi is the imaginary number. A and b are real numbers, but since b is multiplied by I, that makes it imaginary. So something like in that form would be -8 plus 8i, or 6 minus 2i.
Now we're going to try an example for adding and subtracting imaginary numbers. When it comes to adding and subtracting imaginary numbers, it is as simple as it can possibly be. Let me just copy this down first. Now when it comes to adding this, all you have to do is combine like terms. So, what it comes down to is 14 plus 5i. It is so simple. But let's try something a little more complicated. When it comes to subtracting, it is almost the same thing. Now, except we're going to do the opposite operation. Now, when it comes down to this, you just have to distribute the negative sign. So it comes down to -6 minus 4i minus 10 minus 3i. And the rest is so simple. -16 minus -7, that's minus 7i. Action.
Okay, so what we're going to talk about right now is simplifying powers of I. So we know I to the first would be just the square root of -1, which equals I. And then, but then it comes to the problem with I to the second. We have the square root of -I times the square root of -I. But since we know that like something like the square root of 5 times the square root of 5 would equal 5, it would do the same thing as that. So it would be -1. And then we come to something like this, I to the third. Well, since the square root of -1 times the square root of -1 is -1, it would be -1 times the square root of -1, and that would come out to -I because of the thing. And then the square root of 4, we would have 2. We would do the square root of -1 times -1, which is -1, and then that again. And since -1 times -1 equals 1. And then for I to the fifth, we would do, because we already did I to the 4, it would be 1 for the first 4. times the square root of negative 1, which would come out to 1i, which would just be I.
As far as multiplying imaginary numbers go, it's basically what you may think it is. In this simple problem, you simply have a 4 on the outside, which is being multiplied by 3 and 6i. When you solve this, you get down below 12 minus 24i. That's as simple as can be. Now let's move on to something harder. In this problem, you're multiplying an imaginary number. You're multiplying an imaginary number by the same numbers. Now what you get here is 12i minus 24i squared, but you can't have an I squared in the standard form of an imaginary equation. So what you have to do is you have to elaborate on what the I squared is. So since in the problems before I squared is equal to negative 1, you would multiply negative 1 by negative 24, and you would get positive 24. So you get 12i plus 24.
Okay, so what we have here is a problem that is dividing complex numbers. So what we have is 8 plus 4i divided by 2 plus 2i. So what we would do is we would take the inverse of the denominator and multiply that on both sides. So it would be 8 plus 4i times 2 minus 2i over 2 plus 2i times 2 minus 2i. And once we FOIL each one out and all that, we would get 16 minus 16i plus 8i minus 8i to the second power over 2 to the second power plus 2 to the second power. And then we simplify that. We simplify the 8i, so it would come out to positive 8. And obviously the 2's would go to 4 plus 4, which is 8. And when we simplify all this using like terms, we get 24 minus 8i over 8. And then to break these apart, we get 24 over 8 minus 8 over 8i. And that simplifies to 3 minus I.
The end.